large. It doesn't have to be. It's going to go into a lot of this stuff. But why don't I just get to the bare bones so we know what's going on. All right, so it talks about bottles of sherry, and it says nominally, that means normally or whatever, nominally, it's 1,000, right? So they measured it and it's 1,000. And they want to know if there's any suspicion according to 12 bottles from the random sample. And they have all of these right here, okay? And then they want to know, just reading up, because it's all right here, okay, for number 8, assume the volume of the sherry is normally distributed. They have to say that, all right? They have to. And then to investigate using alpha as 0.05. Now, whether the mean volume of sherry in bottles differs, okay? That means what type of test do you think it is? It didn't say increase or decrease. Yes?
Two-tail, because it's not equal to.
Correct. So we're going to do a two-sammy-tail test. All right? Didn't say increase or decrease. All right? So far, so good. So you know what type of test it is. And I wrote some of these things over here. It's like a little schematic and so on. And since we don't know the standard deviation, some of you actually know how to do it on your calculator, if I'm right. I don't know if you do or don't. No? Not exactly. Okay. So I have to do the long way. I can't remember. Okay, so this is where you don't know S, which is standard deviation. So we're going to do the same things that we did before. We're going to find out what all these things are. And then we're going to introduce something else that's called DF. And DF is what's called degrees of freedom. Okay, I'll tell you what that means in a second. We're going to still do the claim, whether it's right hand, left hand, or two-tail, like you all said, including Nick. Emphatically said it's two-sammy-tail. And we're going to do what's called a test stack. And instead of the Z, we call it a T. Wow. And it has the same mannerisms as the same thing as a Z. Except we're going to say it's T on the bottom here. Okay? Not bad? We're just masking a lot of things that look like normal distribution.
Is that X bar or just X?
This is just X. You can put X bar if you want. Okay? It doesn't matter. I just put X because I was flying out of here. Because I had to, like, oh, well, soon it's going to be like this. Ryan, can you write this? Okay? Or could you write this, please? You know, it's... So the biggest thing is we're going to do the same thing as we did before. No different with Z. We're just going to call it T. Now, if you do have your table, do you have your tables with you?
Yeah.
Is there another one on there that talks about T distribution? I'm not sure. Or is it just all Z? Because it's all it is Z?
Yeah.
You don't have the T distribution?
No.
Really? Thank you. Now that's surprising because all of these problems use T distribution. I can't, wow. I'm surprised, okay? Because if you look at some of these, I got these right off the thing here. It talks about Cambridge. So I'm assuming that maybe they give you those values. Can I see it again, Eileen?
Yeah.
All right, I was worried about this. I was like, I'm not going to have enough time to make copies. Thank you. Yeah, they don't do, this is the only thing that you get, huh?
Mm-hmm. We get the pure math and the probabilistic.
I don't know why they did this. Okay, they do give you the standard deviation. It's all right there. Okay, we'll do that right now. Okay, I have to provide a T-table. That's ridiculous. I'll have to talk to Wanda about that. Oh, Mrs. K about it. All right, so I would just give you the T value and so on. I'm just surprised they didn't do this. Because number 6, and I think a couple other ones, use degrees of freedom in T. Maybe, just maybe, they give them to you. I don't know. That's just very, very odd. All right, so I'll continue on. I should have, I was a little doing
This looks
something.
like an older test.
It could be. They should give you a T table, right?
It
Then you just look it up, okay?
Yeah.
It's really, it's no different than looking up a Z, okay? It really isn't. So I'll continue on. I'll just give you the T of critical, okay? So you do all this jazz, and this is what you figure out, right? Based upon your sample, yeah? And then you compare it to what management wants, right? Mm-hmm. And they said it was a 0.05, right? So the biggest thing here, guys, is what do you mean that you have to look at? Well, on the table, it would be a T table, student table, and you T of alpha, and then comma goes degrees of freedom, all right? And I'm serious, so yes, sir?
What is degrees of freedom?
Ah, there's the $64,000 question. That's an enigma wrapped up in a Chinese.
Didn't you get that question wrong then?
Huh?
Did you get your $64,000 question wrong then?
You're not funny. You're not funny.
You're not funny.
Yeah. To my
set
shame.
yourself up for it.
Yes, I did. Thank you, Kennedy. Yeah. So the biggest thing is degrees of freedom, because we don't know, even though this is normally distributed, it's not going to have the same mannerisms as the perfect Gaussian. So what they do is they say, well, we're going to normalize it by maybe the mean, or it's not, or whatever, is in there. So we're going to subtract it off. So it can do this type of Gaussian. Now I can go really into it. I have a whole bunch of stuff into it. Maybe I'll talk more about it Friday. But what you're really doing is you're subtracting this, one of the means or the true mean off, so it doesn't affect the critical region as well as where you're finding it. So your t of calculation versus t critical. So remember how we you had sigma or whatever, well, not sigma, but standard deviation, you subtract 1 off of it. The reason why you subtract 1 of it off of it because your true mean is in there. So you want to find the variance of all of the other guys so you don't have it affected by the naught or the null. That's what they're doing it for. And I wrote this down and I thought about it this way. Okay, here we go. Yeah, it was about balloons and everything else or something like that. Okay, I'll read it to make life easy. The concept of degrees of freedom is often with all these other things in math and science. If you take a bus with 6 free seats, right? 1, 2, 3, 4, 5, 6, right? And 2 of the seats are taken. What's the degrees of freedom that you have left?
4.
4. So that would be n minus 2. Well, what they're saying is let's say that we have 5 seats, and then Sam sits his fat butt right there, and then everyone else can for 4. I call it musical chairs. The music starts going around, everybody's going around, the remaining chairs, and all of a sudden Sam hits one. Music starts again, and then Sophia sits there, and then Ms. Ripper sits there, and so on. And then more and more of us are fighting for those chairs or availabilities. It's no different than balloons. Okay? That's what they talk about degrees of freedom.
There's always one less chair.
There's always one less chair. So they go n minus 1. You're really subtracting the mean to get this to be normally distributed. And it's unfortunate that I'll have to give you the t criticals. Okay? Like t criticals this, and then do the same test. Okay? I'm just surprised. I really am, because this is in what is it called? Right from Cambridge. Okay? So, okay, I'll continue with this one, okay? And it'll fall just like it's done Z's, all right? The only thing we got to figure out is S is unknown, right? We don't know standard deviation, right? So, what do we have? Well, we have, this is mu, so to speak, right? That's what management says, 1,000. And what's this guy right here?
N.
That's N. And then all of this stuff, we have to figure out what X bar is, right? Yeah. X bar is equal to all of those X's.
Over 12.
Correct. Over n. Correctamundo. Right. Now degrees of freedom, df, is equal to n minus 1. So that means we take the number of samples, which is 12, minus 1, we get 11. Okay?
That was so hard.
It's so difficult. It's impossible. All right? So Ryan's going to calculate out for us what the x bar is. All right? There's what?
Repeats.
Doesn't matter. Doesn't matter. So whatever that is, you add them up and divide by 12, right? Of course, I have the answer.
1003.
1003 is that superb. All right. Everybody okay so far?
Yes.
Yeah. Yeah.
What's the degrees of freedom thing?
The degrees of freedom is the number of samples minus 1.
What is it for, though?
When you look up on the table.
Okay.
So that means the T critical would be what? Well, alpha is 0.05, right? Comma 11. You would go, do this, okay? On the table, you go T here, and then it would say alpha here, and then degrees of freedom would be down here. So you go 11 and 0.05, and then you get the value, okay?
Yeah.
That's what you're going to do. Or in my class, since I taught statistics for 100 years, with W.G. Gossett, who did the Guinness thing, you do it that way. Yes, sir.
So we still need to get sigma, right?
Yeah, we got to still get sigma, right? So S is that monster thing right there, isn't it?
Yes.
Okay, so can someone read that wonderful thing that's given to you? If you don't have S, you have to do a T distribution, which I'm surprised. If not, then we'll have to go back to the Z tail, which is absolutely ridiculous. So it's going to be 1 over n minus 1, is that right?
Where is it?
Yes, no?
Oh, okay. Yeah.
Is it there?
What?
Bracket?
Oh,
Yep.
where?
Oh, I don't know. It's on my paper right here. E, it's on the purple or green or orange sheet. E of x squared, right? Minus E of, I know it's weird. I think it goes x like this squared,
Oh, S.
over n. And it's S squared right there, right?
Yeah.
Yeah.
So if it's S squared, that's a variance, right? I know it's like, oh my God,
So
right?
before you square root it, it would be,
You gotta do all this first, then you square root it.
and then it would be the.
Yeah, okay, yes, sir.
So the e of x squared for the second one, is it e of x and all of that squared?
That
or-
says the following, good question. This says that you take every individual sample and square it, okay? And add them up. Here we go, n minus 1, right?
Wait, hold on.
Oh,
What?
whoa,
What?
I know that I had to go through this first, I know, sir.
In the brackets.
Yes, sir.
Okay, so there's the sum of x squared. That is, you square each thing, then add them up.
Yes.
And
This, yes, and then this is just the sum of all of that stuff.
And then square
Then
it.
square it.
Oh,
Okay?
Okay.
I have to do it first. I know it's like, I know it's Wednesday, Thursday, Friday. I know it. I know it. I know it. I know it. Okay? I have to do it first to show you.
yeah.
You go like, okay? Because you see that formula and go, I don't know, screw that. I don't want to have that happen to you. I know it. I know it. I was young a long time ago. Exactly. I'll go to the next problem. No way. Don't give them any of your points, okay? All right? So n minus 1 is going to be what? 12 minus 1, right?
I can do that.
11.
Well, it'll be 11. I just, yeah, okay. Yeah, I
Are
know.
you sure?
I know. Are you sure?
Let me plug that.
Now, here we go. Now, this says I take every one of those individual dudes, right? And I square it. So I go 966 squared. You don't have to do this. I'm just showing you to whatever. I know, but Cambridge is going to make you do it, right? Plus, right? Then you go, it doesn't matter the order, right? You get the idea. I'm going to just go downwards, okay? 988 squared plus, I know, right? Then, after all of that jazz, then you take the sum of all of them. I know it's a lot. I know it. So this one's going to be 996, 996, right?
Yeah, the sum is.
Plus 10, yeah, exactly,
I think
right?
it's 12,036.
I got 1207 2434.
Whatever that is, right? 1006 plus all the numbers, and then divided by 12, bracket. Then when you get all that insanity,
You have to square it.
You gotta square.
I have to square it, thank you. Thank you, Mrs. That's right.
You remember the last
No, that's fine, I know what you did, that's fine. Don't be, if, yeah. And then after you get all this jazz, then you square root it. To save time, you just did it, and guess what it comes, I think it's 5-point change.
The whole thing.
Yeah, so if you get, let's say, 39.7, you gotta square root it.
Oh,
Because that's
oh.
variance, right?
Yeah.
That's variance.
Wait, hold on.
Go ahead.
Alright, so you add them all together.
Okay, well, let's start again, right?
Okay.
It's 1 over 11, like,
No, I have a question on that last part.
yeah. You add them all up,
Add them all up and square it, right?
yeah, then divide by 12.
Add up all that data and you get 12,036.
Yeah, whatever that was, yeah, and then
Yeah.
square it,
You square it.
and then divide
and
by
you
12.
144865296
Divide by 12.
divided by 12.
That's that number here.
12072.
And then you're gonna subtract it from the sum of all that jazz. Sum of the squares. I know.
Them individually.
Yeah, yeah,
Add them up.
I know.
Okay, so I guess you're gonna get a big.
Now, you remember, you guys did standard deviation, I told you it's gonna take me a while. You guys did standard deviation with me a while ago, right? Yeah, and which one's easier?
Not doing it.
Not doing it is the easiest method, right? Not doing it, okay? So if not, then you gotta do the average that you did and subtract the average from each one of them over n minus 1, remember?
Yeah.
You remember that one? I made a table,
Yeah. Wait, so
whatever, right?
So
This
what's
is Cambridge, because you're not gonna, thank you, and get lost, okay? See, that's for sure, that's for sure.
29.64.
He's right, 29.64.
That's the
Wait,
final
you
answer
have
for
the
S.
whole thing?
Now, now take the square root of it,
What do we need to take? Oh, because it's variance.
okay? All right? I know it sucks, it's a big thing, I know it's a long thing, because I said to myself, I can show how to do the way I did it for 100 years, but you're gonna be at Cambridge going, I can't remember what the heck I did for Murmer. So there's this formula sheet, that's what you have to do, yes ma'am? It's what?
The standard deviation formula?
Yes, it's both?
It's on.
You can do either then, okay? I might as well show both, Mr. Epler.
5.44. Yep. How did you know that? Without the calculator.
Okay, 5.44 something, 6, 4, 6, 5?
4.
4, 3/4?
Yeah, 44426.
Okay, all right, there's your standard deviation, okay? I'm showing you either one to do, okay? Because how many marks is this? This sucker's an 8.
10.
10, yeah, 10. That's 10 points, guys.
That's a lot.
That's
Wait,
a third
that's-
of what
that-
we need to pass.
That's a 10. That's a third. How many people have you heard?
Wait, how are we finished?
Oh,
Pardon me?
This is really old. It
Not
still
yet.
says March
10,000.
next to the numbers.
All right.
That's-
Yes,
I
okay.
bet money it's only like 6 points
That's
now.
the old.
Yeah, maybe.
Is it
Either way, yes, ma'am.
That's 29 points.
Yes, ma'am. And it comes out to 544. You always use the positive, right? Okay, yes,
I
ma'am.
did T calculated. It's 1.91
Just found
with that S
one of the
value.
things that
With the T of critical?
Yes.
Wait, how did you find that?
Yeah,
You plug it
he's using Z's.
you still need to
But it's the same formula.
find the calculation.
Yeah, okay, yeah, you're over here.
Oh, yeah.
All right, okay, hold on, guys, please. All right, so the first thing we have to do is do the claim and all that other jazz, right?
Yeah.
So, the first thing says, since you know it's a two-tail, right?
Yeah.
You got the ho and the ha,
Yeah.
right? So, mu is equal to what?
1,000.
Good man. And then mu is, now he said it's two-tail, it's going to be what?
Not equal to 1,000.
Good man. All right. Nick, be quiet, right?
Yeah.
Do we know everything else? We know alpha, we know n, we know mu, hey Sam, we know x, right?
Yep.
Or x bar, right?
Yes.
And we know s. And I put an x bar there.
We don't do that.
And we know and df, degrees of freedom, right?
Yeah.
And you should have that table. I don't know why.
Mine's one.
Okay.
We know degrees of freedom. We've known that ever since 1776.
Well, actually, it came out. Yeah.
No, I didn't.
So that's the first one, right? Second one is the claim and all that stuff, right? So then, let's go to number 3, okay? Claim, we already did 1 and 2. And then 3 is going to be like what Nick said. It's going to be x bar, which is 1,003, is that right?
Yep.
Yeah, it's 1,003 minus 1,000.
Mm-hmm.
Over. Oh, pardon me?
What are we trying to get in between?
Well, we're gonna see where it falls, okay?
1.9.
Yeah, you already did it all, right? I'm just putting all the values in here, okay? 5.44, which you figured out,
Yep.
over the square root of 12, right?
Yep.
And that roughly comes out, as Nick and company said, 191, right?
Yep.
Now, you would have to look up on the table, which I'm surprised they didn't give you. Maybe they don't do it anymore, I'm not sure, okay? But, I mean, I looked at the most recent one, and they do, the ones that, Mrs. K left me, they do the same thing. They do T distribution, okay? Yes, sir.
So you cannot compare Z of 1.96 to T calculated of 1.91.
You would have to be given the T of the critical value, right? They would have to, I mean, unless you have to look it up on the table. That's why we have to do that degrees of freedom stuff. All right? I know it's preposterous, but it's on there. It's even here on the, remember the ones I told you I like and so on? Well, it's on there as well. So unless they dismiss the whole thing about student distribution, which I find not possible, right? So what I could do is probably give you a T distribution table, all right? And you look it up. Or what I'll probably do is just give you the value.
So how do you?
How do you know, right? How do you know? Well, you know by the basis of this, right? That's what you would do on the table. And I'll show you in a second. Yes, sir?
I find it funny how Britain is trying to teach us about degrees of freedom and we taught them all about that.
Yeah, yeah. So, just to draw the picture,
Not history class.
let's say you looked up the value. Just let's say for grins and giggles, you looked up the value, and it comes out to be, because I have it here, minus 2.201. Minus 2.201. I know it's different than 196. Even if you use 196, watch.
They're both negative.
Positive, thank you, Ken.
Oh, okay.
You're ahead of me.
And that will always
That's
work.
the critical values. This is T sub C. This is our good old Z. All right? Watch. It's okay. If you get lost in space, you're still okay. Because,
Not really.
yes, you are. Look where 191 is. Where is it?
On the inside.
It's on the inside. 1.91's here somewhere, right? No, you don't. You fail
Failure
to reject, or you accept the alternative.
Except the
Oh, sorry. You failure to reject, so you accept the null. Failure to reject the null means I accept what parents are saying.
You go into the red district.
I didn't get 0.6.
All right, so
Or what?
1.91,
I didn't
right?
get that.
All right. Well,
I got 1.99.
well, you got 199.
Yeah.
Try it again. It's going to be 3 over this thing, right?
Yeah. And I got 4 4.71118.
I think there's a
I
calculator
got
here.
0.6.
I didn't round.
I think there's a calculator here.
Wait, hold on, what is it? 5.4.
I got 1.9.
I got 1.92.
Yeah, that's what I got.
So it's inside here,
I
right?
got 1.91.
That's
You
what I got.
accept
1.908.
the knot, or you failure to reject the knot. It's both the same thing.
So how are we gonna find the T value?
I would probably give them to, I would give you the T critical value,
So
right? I know.
couldn't we just use the Z value?
I know it's the-
Well,
I'm not
okay,
getting it.
hold on, please, hold on. Caitlin said another great thing. She said, "Can we just use the Z's?" Okay. Look at the difference though between the T critical and so on. This gets more flattened out compared to the the classic normal distribution and so on. That's why he was doing it in Guinness at Guinness Brewery, because he was trying to get it as close as he can to the Gaussian. That's what he was doing. Now, you should be given those tables. I can give them to you, but if that's not on your sheet and you know that's the sheet you're going to use, I'll talk to Mrs. K about that. I talked to her briefly about it beforehand, yes.
So can you always compare the T value to the Z value? Would that always work out like it did there?
Well, let's say, how about if you had a 2.0 or so? How about if it was really close to 1? Here it worked perfect, right?
Yeah.
And so on. All right? Okay, so I don't know how much time is left.
1 minute.
Done? All right. So, guys, hold on for a second. I'm definitely going to have to work. Okay, hold on, please. I want you to work on stats 2. I'll tell you which ones, okay? Number 6. Number 6 is perfect. It talks about Z's, okay? You should be able to automatically get it, no problem, okay? Not a problem there? No, remember, that's okay.
Which
All right.
number 6?
Number 6 is on the front page, thank you. Okay? Next one. So you have so you should practice what's going on, okay? And then you text and tell your friends, hey, remember, it's not good. I didn't say that. That's not recorded. That's good. So the next one here, all right? So circle it for me. Number 6 is, and put a Z next to it, okay?
Which 6? The first 6?
The first 6.
Yeah.
All right? Not bad so far. What's the next sheet? Is it 3 and 5? I can't remember. What's it say?
6 and 3.
6 and 3? Okay, so 6 and 3, right?
To do both of those?
I have to get it squared away here. 6 says is it the lifetime of batteries or something, or no?
Yes.
Yeah, batteries. All right, so that one is, because I get confused really quick over simple things. I just do. Let's see here. So, batteries is 100, right? So, no.